Hey, in this video we'll be using SDL to load images, to render them to the screen, and then we'll talk about the coordinate system that SDL uses. So I'm starting off from this SDL base project that we had worked on the last video. So this just has a basic main loop, and it initializes SDL, draws a rectangle, and quits when you press a button, when you press escape key. And what I'd like to do is make a copy of this so I don't have to change it, so I can save it for later to make more copies, more projects based on this one. So I'm going to go to my projects directory. This has all of my projects in it, Visual Studio projects. And the SDL base solution is right here. Now there are a couple of things you can do. You can copy the whole solution, duplicate it, put it somewhere else, and rename it. What I'm going to do, I'm going to try to get a copy of the project in the same solution. So in this solution folder, I have my solution file right there. I also have a project folder, SDL base. And in the project folder, this is what I have in my project, the main.cpp, and this is the project file itself. So those are the two important parts of this project. So I'm going to back up here into my solution folder. I'm going to copy and paste it in the same spot. So there I have a copy of it. And I'm going to rename it. I'm just going to rename it images, because we're going to be working with images. SDL base images. Open that up. And since I said these are the only two real important things, you can delete the filters. And in this debug folder, there's just some temporary stuff. So we can delete that. It'll get regenerated when we build the project. And here, we can just rename this images. There. So when you have a renamed project, this will work. We can now import this project into our solution. There is a slight detail that the root namespace is going to not change. It's going to still be SDL base, the old one. But I don't think that's going to affect anything in our C++ work here. But be aware that that hasn't changed. So when I go back to Visual Studio, right-click on your solution, and then Add Existing Project, because we have a copy of one. Go to the one that you made, the copy, and choose the project file. So now it's added it in, but they're still called the same thing. So I need to figure out which one of these is the right one, the new one. It's probably the one that it just started highlighting for me, but just check. You can right-click and go all the way down to Open Folder in File Explorer, and that'll show you, okay, so this one is in the SDL base project directory, so that's not the one I want. And this one, yep, that's the base images one. Good. So I'm going to rename it here. Right click and go to rename. That way I can keep them apart, keep them separate in my head and just at a glance. And that also means that this main file, this is for that old project. I'm going to close this main file and reopen the one from base images. Now another thing about this is adding it to the same solution. One of them is bold. Do you see the darkened letters there? And the other one is not bold. The bold indicates which one is the startup project, the current project. And when you press local Windows debugger to run it, it's going to use the bold one. So I'm going to change that. I'm going to right click on the one I'm working on and go to Set as Startup Project. Choose that. Now, that's the bold one. You can see there. and this will run. I can build this and check it out. And it should work just fine. It's a copy of the other one. And there we go. Just what we expect. Press escape to quit. So now we want to load an image. With just SDL, it only supports loading bitmap images, which is a very specific image format. We'll be using a different library later to load any type of format, well, any that we care about. There are a lot of formats. But right now we're just going to load a bitmap image and show you how that works. So before I get into my main loop here, I'm going to load the image. I'm going to make an SDL surface pointer. So this is going to be a pointer to an SDL surface object. I'm going to call it surface. And I'm going to use a function SDL load BMP, bitmap file BMP extension. And that takes the name of a file. So I'm going to have to find a file to load. So let's go look for it. You should have a bitmap file somewhere handy. I put mine, I have one, so I put it in my projects directory here so I could grab it. It's just a little smiley face that I made. So I'm going to copy that, bring it into my project. Let's see, SDL base solution, and then base images project, and paste it into my project directory. So this is, when I run my program, this is where it's going to look for images and other data files, right in the project directory. Back to Visual Studio. That file was smiley.bump. Don't forget the semicolon. And that loads up the image, but it loads it into a surface. A surface is just a memory container, so we can't really render with it. We have to send that information, the memory that represents this image, we have to send it to the graphics card, and that way it's stored as an SDL texture. So we'll make a pointer to an SDL texture, and I'm going to call it, well, I want to call it image. And then set that to create texture from surface. And we're going to just, oh, we have to give it the renderer. So right here, the renderer is expected and the surface that we're using. That'll make a copy of the surface on the graphics card. And since it makes a copy, and then we can start using this image to render, we don't even need the surface in memory anymore, so I'm going to delete it. It's always a good idea to pair your creation calls, this load BMP, with a deletion call, something that gets rid of the memory. So SDL free surface will do that. That frees the memory that is allocated for that surface. So now that's gone. After you free a surface or free a pointer, any type of pointer, be sure that you never use it again. It's not safe. It can make your program crash. One way to be a little more careful than just saying don't do it is to set that pointer to null. Then you know it's not pointing at anything, and if you run into a problem later, it'll help you track it down. So we now have a texture that's storing that image, the smiley bitmap. And we want to be able to draw it onto the screen. So the function we'll use, I'm going to put it right under all this rectangle stuff, is SDL render copy. So render copy, copy a portion of the texture to the current rendering target. So we give it the renderer, We give it the texture we're using, which is image. And now it expects a source rect, a source rectangle, and then a dest rect, a destination rectangle. The source rect is what part of the texture you're going to be using, and we want to draw the whole texture, the whole image, so I'm putting null. We don't have a source rectangle. And then the destination rectangle, we need a place to draw it on the screen. So I'm just going to reuse the rectangle we have here. We drew we filled that with a flat color before, but I'm going to reuse it. So that'll draw over that. And we should be able to check it out, see what that does. Alright, nice. So we got the thing rendered here, this smiley image, and you'll notice it took the dimensions of the rectangle. It's the same width and height as that rectangle we drew. So that might not always be what you want, but that's the way you can stretch it and scale it, make it bigger and smaller by changing the width and height of where it's drawing. Also, it's covering up this rectangle that we drew. So I'm going to delete the rectangle, the filling call and the set color call. We don't really need those if I'm just going to be covering them up. So now it's just rendering the image on that rectangle. But what I'd like is to use the dimensions of the image, the proper dimensions. So we'll have to ask SDL to tell us how big that texture is using SDL query texture. And this takes the texture, which I called image, and then it takes a bunch of pointers in a row. The first one is the format. So if we gave it a pointer to a format, it would tell us, it would fill in the format object. I don't really need that information, so I'm going to put null. The access pointer is a texture access, tells you how the texture is being used, and I don't really care about that either. But I do care about these, the width and the height. That's what I'm looking for. So I'm going to put in a pointer to the rectangle's width and a pointer to the rectangle's height. There. So save that, and it doesn't really matter what I put here, because it's going to be overridden and written over in this call. Query texture is going to put some values into those variables. So I can even delete these two lines. Or just leave them, whatever. But I'll delete them. You can try that out. Now it should show it at the full size, which I believe for this image was 256 by 256. There. So about double what we had. Bigger and square. So the right dimensions, the right aspect ratio. It's not squished. Looks good. And once we're done with using the image, the texture here, we should definitely free it. Just like we freed the surface memory, we should be freeing the texture memory. And that should be done after we're done drawing with it. So before we quit, SDL destroy texture. And give it the texture to destroy, which was image. And that's it for cleaning up after yourself. Alright, so now we're drawing an image here, and you'll notice that this code right here, creating the rectangle, querying the texture size, and copying it to the screen, this is all the stuff we need to draw the image. But it takes up 5 lines of code right here, and wouldn't it be nice if instead of all that we could just write something simpler, like draw image call. And then, well, we're using the renderer, and we're using the image, and, well, we're using the full dimensions of the image, so that doesn't matter. But the X and the Y matter. So what we really need here, the renderer, the texture, and where we're going to put it. And we put it to 50, 80, X and Y. So I would love to have a function like this instead of calling and writing all of this every single time I want to draw an image. So let's define a custom function just like this, and that'll be how we use it. So I'm going to cut all of this, take it out of here, and this will be so much nicer if it looks like this. Draw image is what I called it, so I have to go up here above main, and I'm going to make a function. So the functions we've had so far have had return values like integer, but we're just drawing something, so we don't really need to return anything. There would be no point, it wouldn't be meaningful. So I'm going to type void. Void as a return type means that the function doesn't return anything. And draw image is the name of the function. So that's what my function will look like, but we need some parameters here. If I scroll back down to how I wanted to use it, we have a renderer, a texture, and then X and Y coordinates, which were both integers. So SDL renderer star, the renderer, SDL texture star, the texture, I'll call it image again, and then an X integer and a Y integer. And then in the body here, I'm going to paste what I had there. Now this almost works. We have the renderer and we have the image, but we're not actually using these X and Y yet. That's what I would use in place of these numbers. This is the X coordinate, and that's the Y coordinate. So just replacing those constants that we had, so that now they're parameterized. We can use X and Y instead. And this does all of the same stuff. If I run that, it should build and work just the same. Good. So that's a little process of function design there, writing out what you want and then making the function that you wanted. It's also a way of refactoring code. Refactoring code is when you change it to try to change the structure, but keep the functionality of the code, the way it works, should stay the same. So now we have this custom draw image call, and we could draw that image anywhere we want now. 90, 200. And if we ran this, we would have, hopefully, 3 times the image it's shown on the screen. Whoop. Overlapping a bit, because the image itself is 256 pixels wide. But this shows us a little bit about SDL's coordinate system. You'll notice that we started off over to the left side. The left edge of the screen here is the 0 x-coordinate, and as you increase the x-coordinate, you draw your pictures farther to the right. If we take a look at the y-coordinate, let me change the y-coordinate a bit. I'll make it even bigger so that they won't overlap so much. Okay, so the y-coordinate goes from the top down, which is a little bit strange if you're not used to it. So 0 is up at the top, and the y-coordinate increases downward. So this was my first image at 80 pixels down, and then my next one 300 pixels down, and then my next one. So your origin, if you were talking mathematically, is actually up here in this corner, right there. The 0, 0 point is right there. And this has some consequences. The reason it is this way is because it's kind of the classic coordinate system for computer graphics. If you imagine a long time ago when people first started putting graphics on screens, we didn't use LCD or LED monitors, and the cathode ray tube monitors that we did have had a CRT scanning beam, an electron beam that ran across the screen and then back to the other side, and it kept going and going until it got down to the bottom. So it started up at the upper left corner and ended up at the bottom right corner. So the way graphics were drawn, the memory was actually laid out that way as well, so that the electron beam and the way the memory was uploaded to the video memory kind of matched. That made sense back then. Not always so much now, but it's kind of a standard thing for certain systems. If you use OpenGL or a game engine, you might use a different coordinate system, and that's fine. But you might want to at least try this one out and try to get used to it and see how it goes for you. The only real implications it has is that it implies a left-handed coordinate system, and if you're well versed in vector math and matrix math and all that stuff, and trig functions, that means something. When your coordinate system is left-handed, cross products have a different result, but also angles are reversed. So instead of, well, I can't really indicate it well with just a mouse, but when you go around the unit circle or just increasing an angle in a triangle or something, it's going to go the opposite direction. So because the y-coordinate is inverted and greater values are down at the bottom of the screen, it helps to know what the size of the window is in order to position your images correctly. So if I delete these, actually I'm going to delete, I'll delete those. I can put this image into the upper left corner at 0, 0, and that's totally fine. But if I drew it in the lower right hand corner, or naively tried to do that, if I look up here, I made my window 800 pixels by 600 pixels. So I've put 800 by 600 as my x and y coordinates, and try that out. Then that's definitely not what I wanted. I have my image drawing just fine at the origin, 0, 0, but way down here, it's actually drawing off of the screen. I want it to draw on the screen, so drawing it at the corner there is not the right thing. So to draw that image on the screen, we're going to have to give it an offset in its coordinates. And to get the whole image on, we'll need to know how big it is. So we'll make another call. We'll make another call into SDL query texture. Give it the texture's name. I don't care about the format or the access. and I'm using two variables for the width and the height. So you'll notice I declared them in one single declaration, so they share the same type. It's just a shorter way to do it. And this is going to tell us the full width and height of the image. And then when we draw it, we want it to be offset by those values, shifted in the x dimension by the width and the y dimension by the height. And that should put the image onto the screen. Yep, there it is, right in the corner there. So we drew one at the origin, and it went off to the right and down in the positive x and the positive y. And then because it draws that way, we needed to offset our drawing point. So now it's right here, because it draws to the positive right, positive x and the positive y downward. There. And that's it for this video. See you next time.